Welcome back. This is Unit 2, Day 5 notes. If you missed class today or if you just want to rewatch it, Miss Bowman's going to ramble for like 45 minutes. It's going to be awesome. As usual with these videos, if you haven't seen one before, I'm going to ask you to pause me as a video to try the problem. These tend to be long lectures, so take brain breaks as you need, stretch breaks as you need. Do whatever you can do to make sure that you have the mental capacity to kind of absorb the material. So whatever that looks like for you, I am going to go through the Day 5 notes, geometry of the derivative. And today we're just going to kind of sum up what we've learned about the derivative in this unit and the second derivative. So we're going to kind of add on to what we did last class and the Day 4, and then also just kind of tie it all together in a way that kind of makes sense and is meaningful. So we have some conclusions that we're going to be able to draw today. So if I give you f of x, like a function, you're going to be able to tell me things about f prime and f double prime. If I give you f prime of x, you're going to be able to tell me things about f double prime and f of x. And if I give you f double prime, you should be able to tell me things about f of x and f prime of x. So to help us get us going, we're going to kind of organize this information in a nice little chart, okay? So we're going to summarize what we've learned about the relationship between f prime, and f double prime. Remember, f of x is a function. F prime of x is what we call the first derivative. It gives us the rate of change of a function. And the second derivative, or f double prime, gives us the rate of change of the rate of change. So let's kind of go through what we can say here. And given this information about f of x, is there anything that we can say about f prime and f double prime? Now, if you want to pause me and kind of think through this, I highly recommend it. Try to figure out what we could say about f prime based off these things about f. What could we say about f double prime? I'm going to go through, so if you're not pausing me, let's get going. If you are, pause me and then unpause me. Okay, great. So if f of x is decreasing, what conclusions can we draw about f prime of x? Well, if f prime of x is the slope of f of x, and we know our function is decreasing, that would tell me that the slopes are negative. So what I would know about f prime of x is that it would be negative. Okay, or you could say less than 0. That's the same thing as saying negative in a shorter way. If you want to write any g period, then that's good as well. Okay, now if we know a function is decreasing and that is all we know about the function, is there anything that we could say about f double prime? Well, if I think about it, I could decrease. If I'm a decreasing function, I could look like this, which means the second derivative would be 0 because there's no concavity or change in the slope. I could be decreasing like this. That's getting more negative or steeper. It's frowning. That's concave down. I could also be decreasing like this. So just the fact that I'm decreasing doesn't give me enough information because I don't know which scenario I have. So for f double prime, I'm going to write CBD, which kind of stands for cannot be determined. Okay. Likewise then, for f prime, if f of x is increasing, then I know f prime of x has to be positive or greater than 0. And again, the second derivative cannot be determined. Now, if f of x has a max, min, or leveling point, a leveling point is something like that, where it flattens out and becomes level, I know that the derivative is either 0 or dne. And you're like, well, what do you mean dne? Well, think about your absolute value function. Absolute value function has a minimum here, but the slope does not exist at that corner. So we could say it's 0 or dne. And we're going to add to this row later on in the next 2 units. But for now, I'm okay with 0 or dne. And then the second derivative, again, for now is CBD. But I'm going to tell you that later on, if I have a maximum, I know what concavity I have. If I have a minimum, as long as we're differentiable, I'll also know what kind of concavity I would have. And same with a leveling point. Okay, so we'll add to that. For right now, I'm okay with CBD across the board. Okay, let's go on to the next category that we describe a function. Now we can describe a function as concave up, we can describe a function as concave down, and we can describe what we call an inflection point. Okay, so for concave up, if my function is concave up, now that function could be increasing or decreasing. It just means the curvature has the shape of concave up. So what I could say about f prime of x isn't that it's positive or negative here. If I am concave up, the only thing I know from sure is that my slopes are either getting less negative or more positive. So what the slopes are doing is increasing. So if my f of x is concave up, then I know f prime of x has to be increasing, which means f double prime, if that's the slope of f prime, has to be positive. Concave down then, f prime is decreasing, f double prime is negative. Inflection points. Now for inflection points, let's think about what that would mean for the second derivative. Well, here, I keep drawing the same picture over and over again. Inflection points means the second derivative is 0 and there's a sign change. So if you remember from last class, when we talked about inflection points, you have to make sure there's a change in concavity. So saying the second derivative is 0 is not enough. It has to be 0 with a sign change. Okay, so that's why I have that little and. And then for f prime, let's think about what would happen on f prime if I were to graph it. So if this is f and I tried to graph f prime, well, I know I'm concave down, so I'm decreasing on f prime. Okay, decreasing on the positive side because we're increasing this whole time, so I'll be on the positive side. So I'm decreasing, and then I hit this inflection point where the slope hits 0 because it flattens out. And then I'm still increasing, so I'm still positive, but now they're getting higher and increasing again. So if you look at what this creates, it creates a minimum. So inflection points on f of x are maxes and mins on f prime of x, okay? This chart, guys, becomes like your best friend for the rest of calculus. And so if you are making yourself like a cheat sheet of things or a reference page of things that you just kind of refer to all the time, which I highly recommend throughout this class, I would include this chart. Now, people are like, oh, Ms. Bowman, I'm not trying to memorize this chart. That's fine. You don't have to memorize this chart. One thing I would say to make it a little bit easier for yourself as you're looking at this chart is if you notice these 6 boxes here, okay, decreasing, negative, increasing, positive, maxes and mins, 0 or DNE, those are the same boxes here, minus the sign change. So like really, if you can learn these, then they apply here. And then all you have to remember is I can't decide anything, and this is concavity. So that might help you a little bit as you're going through and practicing that. And we're going to be referring to this chart over and over and over again. So again, it might be in your best interest to start a reference page or a shortcut. You might have added those weird functions we did at the beginning of the year, the step and step stool functions, with the integer function and then that absolute value of x over x function to it. This would be a good thing to add to it as well. Okay, so here's what I want you to do. I'm going to ask you some true-false questions, okay? So here are some true-false questions. I want you to pause me and take about 1 to 3 minutes, depending on your brain speed, okay? Take 1 to 3 minutes and think about these. It might be in your best interest to save number 1 for last, get your brain going, and answer these true-false questions. So pause me and then unpause me, and I'll welcome you back. Okay, welcome back. Thanks for unpausing me. So to go over the answers to these, I'm going to save number 1 for last because that one's a little bit more intense. If f prime is increasing, let me just go ahead and get rid of that highlighter real fast. So this one says, if f prime is increasing, then f of x is also increasing. So if I refer to my chart, if f prime is increasing, all I know is that the function is concave up. But a concave up function can be increasing or decreasing, so this is false. If the second derivative is positive, then the first derivative is increasing. That is true. If the second derivative is 0, then f will have a max or a min. That's false. It has a potential inflection point there. Okay, if we have a function in its graph for f of x, then it is possible to find the function and its graph for f prime of x. This is true. You have enough information. If you know the function, you can use the limit process to find the derivative function. And if you have a graph, you should be able to graph it as well. Okay, if we have a function its graph for f prime of x, then it's possible to find a function its graph for f of x. This is false. Okay, now can I sketch a potential f of x graph? Absolutely. But f prime of x does not give me values of f of x. F prime of x gives me behavior of f of x. So f prime only gives behavior and shape of f of x, not values. And we're going to be practicing this in a few minutes. We're going to really start looking at graphs of stuff and what information can I get from a graph. Okay, last one. If f of x is concave up, then f prime of a is less than f of b minus f of a over b minus a for a less than b. Okay, so what does this mean? This is saying the slope at a has to be less than the slope between a and b. So if I draw a concave up function, let's play this out, and I pick a point a, and I pick a point B. Now, the only qualification is that B has to be less than, or B has to be greater than A. So I can pick a B anywhere. I'm going to put a B right here. And I draw that line, that the slope of that line is greater than the slope of this line. Now, in your brain, you're like, but this line is steeper. But this is a really large, like a really low negative number. And this is still negative, but it's less steep, so it'll be a higher negative number. So that's true. Now, if I were to do this where this is A and this is B, let's try it again. Negative slope, zero slope still holds true. If I pick it, so this is A and this is B, negative slope, positive slope, the secant line slope is still bigger, so this is true. So that was just to kind of get your brain warming up and thinking about these. It's going to take some practice and time. Be patient with your brain, y'all, on these, because it needs some sink in time. And that's the nature of calculus. That's why a 65% on the AP exam gets you a 5, because they don't expect you to master every detail. Some of these details took me a long time for them to really sink in, and that's completely natural. So if you're like, dang, those were hard and I missed all of them, that's totally okay, because eventually you'll be able to get them all. Okay. So just again, be patient. I'm going to tell you that all the time. Be patient with yourself. Be patient with your learning. Okay, so here's what we're going to do. Now it's just going to be pause, practice, unpause. That's all we're going to do. So we're going to just do a ton of examples of how to read graphs of different things and pull out information. Okay, so here's your first example. And in class, we probably didn't get through all of these. I'm going to try to get through all of these in this lecture, so at least you have me going through each example. You just kind of have to like go through the YouTube video or the link and fast forward where you need to be. So pause me, and here's what I want you to do. I want you, if this is a graph of f of x, I want you to tell me everything you can about f prime of x and everything you can about f double prime of x, okay? So you're going to answer these questions based on this graph of f of x. So pause me, try it, and then unpause me and you'll hear the answer. Okay, so welcome back. I hope you were able to at least answer some of them on your own. And then we'll go through the rest of them to make sure that you understand. So f prime is positive. Well, I always have to ask myself, who am I looking at and who are they asking me about? And then I'm going to go all the way back to this little chart here, and I'm going to keep thinking about this chart over and over and over again. Okay, so f prime is positive. What does that mean for f of x? That means f of x is increasing. So this is going to be negative infinity to 2 union 4.5 to 7. F prime is negative means f of x is decreasing, which is from 2 to 4.5 and 7 to infinity. Now, if f prime is constant, that would mean that f of x is linear, and that is not the case. So I'm going to put D and E, or does not exist for that one. F prime has roots. Well, roots are x-intercepts, or what we call solutions to a function, roots of a function, x-intercepts. So I'm thinking to myself, okay, if f prime has an x-intercept, that means we're looking for where f prime of x is equal to 0. Well, my 0 slopes are right here. So that's going to be at x equals 2, 4.5, 7. And I just made a list, and that's totally fine. If I wanted to write it as ordered pairs, it's fine, but a list of x is just as good. Okay, now we're going to switch gears. F prime increases. So if f prime is increasing, what does that mean for f of x? That means f of x is concave up. So I'm looking for the concave up. So this is where we're going to really kind of look at it, frowning, 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 till maybe here. And then I'm smiling till about here. And then I'm frowning the rest of the way. So I'm going to say we're concave, f of x is concave up from 1, 2, 3, 4, 5, 6, from 3 to 6, which means that f prime is increasing. F of x is concave down from negative infinity to 3, and then from 6 to infinity, and that means f prime is decreasing. Now, f double prime being positive, that is the same question as f prime increasing. F double prime being negative means f prime decreases. And f double prime is 0 would be any place we change concavity. So that's going to be x equals 3 and 6. Now, f prime has so if f prime has a local maximum, that is not these points, okay? If f prime has a local maximum, I have to think about what that means for f of x. And going back to our table, if f prime has a maximum, then f of x has an inflection point. So that's going to be at x equals 3 and 6. Notice how these two are similar. Okay, so now if I wanted to sketch f prime of x, I totally could. All right, so what I would do first is I would sketch my roots. I have roots at 2, 4.5, and 7. Now the other things I'm going to know here is I'm going to kind of like make some notes to myself at the bottom just to kind of help me. I know that f prime is positive from here to here. So from here to here, we're positive. And then from 2 to 4.5, we're negative. From 4.5 to 7, we're positive. From 7 to infinity, we're negative. Okay, then I also have this increasing, decreasing information. So I know from 3 to 6, 3, 4, 5, 6, in here, we need to be increasing, and then everywhere outside is decreasing. So if I'm doing that from 0 to 2, I'm going to be on the positive side and decrease. And then from 2 to 3, I'm now on the negative side and decreasing. And then now I'm on the negative side and I'm increasing. Now I'm on the positive side and I'm increasing till 6. And then from 6 to 7, I'm going to be positive and decreasing, and then negative and decreasing. This is a sketch. It does not have to be perfect. Okay, team? And again, we're going to be practicing this for the like the rest of the year. So give yourself some time. It's going to feel difficult. It'll get easier with time. Most people love getting a graph of f of x. The most important thing you can do for yourself is ask yourself the following question. Who am I looking at? Okay, and who are they asking me about? Because it is going to be different than who you're looking at 90% of the time. So if we look at this one, below is a graph of the derivative. So this is f prime of x, okay? What could you tell me about the function? So go ahead and pause me, answer these questions and unpause me, and I'll go through the answers for you. Okay, welcome back. Hopefully you've written something for at least 3 of these, even if they're wrong. The worst thing you can be is wrong. And if that's the worst thing that happens to you today, you are living a pretty good life. Okay, so now I want to know So I'm just going to go ahead so I don't have to flip back, and I am going to quickly make my little chart. So you can see like how fast I can make this chart. And that helps me. Okay, that helps me organize it. Okay, so here I'm looking at f prime of x. They want me to know where f of x increases. So if I want to know where f of x increases, I need to look where f prime of x is positive, meaning it's on the positive side. So if I look, this is the positive side, this is the negative side. We're on the positive side from 0 to 4. And then it looks like, again, it's going to cross 5, 6, 7, 8 and go up. So I'm going to go ahead and say 8 to infinity. Now, f of x decreases. F of x is decreasing when f prime of x is negative. So it is on the negative side from 4 to 8. F of x has a local max or min. So now I want to look at this, and I want to figure out if I have a local max or min. So local max or min on f would be a 0 or an undefined place on f prime. So my zeros are at actually 0, 4, and 8. So all of those would be maxes and mins. Now you're like, but that's an endpoint. Yes, it's an endpoint. An endpoint can be a max or a min in a graph. In fact, locally, it always is. And we'll kind of talk about that as we go through. You're like, oh no, that just blew my mind. I know, I'm good at that. Okay, so second part, f of x is concave up. So f of x is concave up when f prime of x is increasing. So now I'm looking at the increasing intervals on this f prime graph to tell me on what intervals the function would be concave up. So I'm going to say 0 to 2, and then 6 to infinity. So concave down then would be 2 to 6 because it's decreasing. And that's it. And then f of x would have an inflection point when f prime of x has a max or a min. So that's going to happen at 2 and at 6. Now, here's where we get confused a lot. I just told you that endpoints are maxes and mins, which on this graph, 0 is an endpoint. So on the f prime, 0 is a local minimum of the f prime graph. But inflection points have to have a sign change. So we ignore endpoints when we're talking about inflection points because there is no change at an endpoint. It's just a start or an end. So we're looking for these maxes and mins that are in the interior of the domain, okay? So endpoints count as maxes and mins, but they don't count as maxes and mins we look at for inflection points. Inflection points have to be sign changing, okay? All right, so let's just keep on keeping on. And now we're going to try this one. So go ahead, pause me and try this one. I will tell you there's some arrows on here. I just want you to answer the following questions based off of the graph. Okay, again, pay attention to who you're looking at. Also, one note before you pause me, these should all be negatives in quadrant 2. In quadrant, somehow the negative didn't print, but you guys are smart enough to know that those are negatives, okay? But this is a graph of f prime. So always, who am I looking at and who are they asking me about? So go ahead and pause me, try these questions, take between 1 and 3 minutes, okay? And then unpause me when you're ready. Okay, welcome back. At x equals 4, is f, notice that's not who I'm looking at. I'm looking at f prime. Is f increasing, decreasing, or neither? Circle 1, how do you know? Okay, so if I look at 4, what I'm asking myself is, what does the derivative tell me about f of x? Well, it'll tell me behavior. So if I want to know if f is increasing, decreasing, or neither, that's the same question as asking, is f prime positive, negative, or 0? So if I look at 4, I can see that at 4, it's on the negative side. It's at -1. So that tells me f of x is decreasing. And my reason is because f prime of 4 is less than 0. Welcome to a proof in calculus, guys. That's a whole proof right there. Or a justification. Okay. Is there a critical point? Oh, so I forgot to introduce this language earlier. A critical point is just a max, min, or 0, or a max, min, or leveling point. So when I talk about critical points, I'm talking about max, mins, or leveling points, those flat parts. Okay, so I'm asking myself, if f has a max, min, or leveling point, what has to be true about f prime? Well, if this is true, then f prime has to equal 0. Okay, so looking at x equals 2, f prime of 2 equals -4. So the answer is no, because f prime of 2 doesn't equal 0. Now you're like, but isn't that a minimum? And the answer to that is yes, it's a minimum on the f prime graph. That doesn't mean it's a minimum on the f graph, okay? Two different graphs. Is f a 9 positive, negative, 0, or can't be determined? Okay, this is can't be determined. F prime only tells us behavior. So the only thing I could tell you about f of 9, I could tell you f of 9 is increasing. It's increasing at f of 9, and I could tell you it's concave up at f of 9, but I can't tell you where in the world f of 9 is, okay? So it only gives behavior. Is f concave up, concave down, or neither at x equals 4? Okay, so now again, if they're asking me about concavity, I'm going back to my chart. So if f is concave up, f prime is increasing, decreasing, or 0. So really, I'm going to say, is f prime, or constant, is f prime increasing, decreasing, or neither? So if I look at 4, f prime is increasing there. That tells me that f is concave up. And I would say because it's f prime of 4 increases. Or you can say f prime increases at x equals 4. Okay. What is the x coordinate of a local maximum on f? So now we're going to have to do a little thinking here. If I want a maximum or 0, or maximum or leveling point, I'm looking for where f prime is 0. So my potentials are at -9, -5, 5, and 8. So those are all what we call critical points of a function because they're all 0 slopes because it's at the 0. Now, if I want to figure out if it's a local max, I have to do a little thinking. So if I have a maximum, I have to go from a positive slope to a negative slope, okay? Which means on my slopes graph, I'm going to have to be going from the positive side to the negative side. So if I look at -9, we're going from the negative side to the positive side. That means it would be a min on f of x. I also know it's a min because it's in f prime of x. Oh, I just said it. F prime of x is increasing, which means the function is concave up. And the only thing I can have in a concave up part is a min. At -5, we go from the positive side on f prime to the negative side on f prime. That would be a max. So we have x equals -5 is a max. Okay, so let's keep going. Now 5 goes from the negative side back to the negative side. That means that f would be decreasing and then decreasing. So this is neither. This is actually a leveling point. And then at 8, we go from the negative side to the positive side. So that's going to be a min. So really the only one is at x equals -5. And my justification would be f prime of -5 equals 0 and changes. Wow, if I could write in English, let me just go ahead and type that. So f prime of -5 equals 0 and changes sign. Oh my gosh, guys. From positive to negative. If I could spell, I'm just going to put pos to neg. Okay. All right, let's try another one. All these examples. Okay, remember, most important question when you see a graph, who am I looking at? Who are they asking me about? And what is the relationship? So going back to that chart we created. Okay, so who are we looking at in this example? F double prime. Who are they asking me about? F and F prime. Are they asking me anything about F double prime? No, but wouldn't it be nice if they did? Okay, so pause me, try some of these questions. Don't be afraid to be wrong. Okay, I'm going to go over the answers in a minute. Okay, welcome back. So where is the graph of F prime increasing? So now I'm going back to my little fancy chart, which I'm just going to copy the one from right here. I'm going to cheat a little bit, guys. I'm going to copy this. I'll probably keep pasting it on every new slide now. Okay, so now I'm going to paste. Okay, so if I want to know where F prime is increasing, that means F double prime would be positive. So can I tell that from this graph? Yes, it's positive from -2 to 1, and then from 3 to infinity. Where is the graph of F concave down? So if I want to know where the graph of F is concave down, I'm going to be looking for where the second derivative is negative. So negative infinity to -2, union 1 to 3. Where does the graph of F have zeros? I actually don't see anything about zeros in this chart. This cannot be determined. Wow, I just can't even write. There we go. Let's try that. Where does the graph of F have inflection points? That I can tell. I'm going to be looking for where there is a 0 on the second derivative graph and a sign change. So that's going to be at x equals -2, 1, and 3. Where does the graph of F have a minimum? Well, that would be a 0 on the F prime graph, but I can't determine anything from the F double prime graph, so this is CBD. Okay, just a couple more examples. Really trying to get you just to practice these graphs. Let's do 4 more examples. All right. Who am I looking at? Who are they asking me about? Those are the questions that you want to ask yourself every single time. So the graph of the function, ooh, this is a graph of f of x. Okay. Answer the following questions about f. And I'm going to go ahead and paste that little chart, put it down off to the side. Perfect. That I can reverse it. Okay, so notice also that this graph is a little bit different because there are endpoints here, and that's going to come into play for a couple of these. But go ahead and pause me, try to answer these questions based on the graph of f of x, and then we'll go over the answers. Okay, here we go. On what intervals is f increasing? Well, they're asking me about f, and I'm looking at f. So this is just analyzing a graph that I'm looking at. So it's increasing from A to C, union E to G. Now, some people like to put a bracket here at the endpoint. Some people actually put brackets there. It's a big mathematical debate. If you have any questions about it, just ask me in class. Okay, I'll probably talk about it 100 times. I'm going to bracket my endpoints, and I'm going to parenthesis all the other ones. Okay, on what intervals is the graph of f concave up? Again, I'm looking at f, and I'm looking for concave up, so I'm actually just looking for where it's smiling. So that looks like it's going to be from D to F. Okay. At what x coordinate does F have local extrema? So F has local extrema. Extrema just refer to the plural of maxes and mins. So looking for local extrema, that's going to be our local maxes and mins. So we're going to have maxes and mins. I have a max at C. I have a max at G. I have a minimum at E. And then because it says local, these endpoints are also local maxes and mins. This is a local min at A, so I'm going to include that. And this is also a local min at J. Okay, so just looking locally in that area, if it is a low point, then it would be considered a local max or a local min. Endpoints are included. If they don't want you to include the endpoints, they'll say for the interval, and they'll give you the open interval, and that's how you'll know. If it's a closed interval, they want you to include them. Now, what are the x-coordinates of all the inflection points on F? Again, I'm looking at F. So inflection points are where we change from concave up to concave down. I didn't realize that had moved. So that's just going to be from x equals d and F. Okay. Let's try again. Same graph on this next one. Same graph, but now the graph that we're looking at, although it's the same graph, this graph is now the derivative of F on a closed interval. So based off of the fact that this is the derivative graph, what could you tell me about F? So on what intervals is F increasing? Well, F increases when F prime is positive. So that's going to be from, oh, I forgot to tell you to pause me, but hopefully you did. And now you're unpausing me. If not, pause me, try it, and then unpause me. Okay, so F is increasing from B to E, and then from E to I, because that's where the derivative graph is on the positive side. Notice that at E, the height of F prime is actually 0, which means that it's like a leveling point because it's a 0 slope. So it's neither increasing nor decreasing there. Hence why I excluded it and I didn't go straight from B to I. I went B to E and then E to the I. On what intervals is the graph of F concave up? So if F is concave up, F prime has to be increasing. So this is going to be from A to C, union E to G. At which x-coordinates does F have local extrema? Okay, so if I'm looking for local maxes and mins on F, I have to be looking for zeros on F prime or endpoints. So I'm going to say B, I, A, and J. Okay, notice that I didn't really include E. I didn't include E because it's actually not a local max or a min. It goes from positive slopes back to positive slopes. That's going to be a leveling point, so that's not a max or a min. Whereas B, because we go from negative slopes to positive slopes, that's going to be a min. Positive slopes to negative slope, that's going to be a max. And then the endpoints, this endpoint, we have negative slopes after it. So if I imagine what's happening, I have a point somewhere at A, I don't know where, but then I have negative slopes coming off of it. That's going to be a max. And this one, wherever it is on F, which again, I don't know the location, but I know that the slopes coming to it are negative, that has to be a min. Okay. What are all the x-coordinates of all the inflection points? Okay, so if I'm looking for inflection points on F, I am looking for maxes and mins on F prime. So that's going to be x equals C, E, and G. Notice here, do not include the endpoints because inflection points have change involved, and there is no change at an endpoint. So you're just looking for the maxes and mins on the F prime graph. Okay, so last two examples, here's what I want you to do. You're going to do both of them at the same time by pausing me, trying both, and then unpausing me. I'm going to give you some descriptions, okay? And based off those descriptions, I want you to sketch a graph of f of x based off all this information. I'm going to give you things about f, f prime, and f double prime. So this is kind of putting it all together. And so you're going to do number 8 and number 9, and then unpause me. Okay, welcome back. So I'm going to give you some strategies for sketching. You did a lot of sketching in Math 4. Well, you did some sketching in Math 4. But I'm going to kind of help you with, because we're going to do it a lot in Calc. So plot your points because those are going to be easy to point. Now I'm going to scale this by 2 because I don't have enough. So negative 1, 2, 3, 4, 5, 6, 7. I guess I could, but I'm just going to count by 2s. To help myself here. So negative 2, 8. F of 0 is 4. f of 2 is 0. And I cross those out so I know I've taken care of them. Okay, now all of the rest of it is going to give you behaviors. Now these are telling me that the derivative is 0, so those are 0 slopes. So what I do is at 2, I go straight across like a little baby tangent, and at -2, because I know it needs to go flat there. Okay, so I've done that one. And now the rest of it, what I try to do is write myself notes beneath the graph so that I can sketch it. So it tells me the derivative is positive for when the absolute value of x is greater than 2. So that's going to be from 2 and -2 out. I know my derivative is positive, which tells me my function is increasing. And then everything less than 2 is going to be negative slope, so it has to be decreasing. Okay, so I marked those. Now this, f double prime being negative, tells me I'm concave down. So from anything left as 0, I'm concave down. And then anything greater than 0, I'm concave up. So when I sketch this, I kind of go to the point that they gave me, and I'm going to sketch this part. So coming to this point, I need to be increasing and concave down. And then from -2 to 0, I'm decreasing and concave down. Then from 0 to 2, I'm decreasing but concave up, so smiling. And then I am increasing and concave up. So it looks something like that. Okay. I know I went through that pretty fast. Feel free to just take a break, pause, marinate on it again. It's just going to be taking time, so be patient. All right, now you've already tried this one. Now, some of you after the first one are like, ooh, I want to redo this one. You know, that's the nice thing about asynchronous learning. You can always just pause me and do what you need to do and then come back to the lesson. Okay, so I'm going to graph my points first. So f of 2 is 1. F of 4 is 4. Okay. F of 6 is 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh, to the top. Okay, so now I'm going to write myself notes. F prime is negative for x is less than 2 and greater than 6. So I'm going to draw a little dotted line at 2, 3, 4, 5, 6. Okay, so everything left of 2 has to be decreasing. Everything right of 6 has to be decreasing. Okay. Ooh, f of 2 is 0 and f of 6 is 0. That means we're going to have a 0 slope here. So maybe just draw a little baby tangent that's like flat to let yourself do that one. And then f prime is positive between 2 and 4. Oh, they split it at 4. So we're increasing and then increasing again. So 2 to 4 and 4 to 6. Notice how they skipped over 4? Interesting. Okay. F double, now I don't have a way to mark that, but I'm just going to think to myself that's possibly an inflection point, maybe, question mark. Okay, so now let me see what else we have. F double prime is 0, so that means F is concave up for everything less than 2, so we got concave up, and from 2 to 4, we're concave up. And then from 4 to 6, we're concave down, and anything greater than 6, we're concave down. Oh, that's why they split it. Okay, so I need to decrease and be smiling until I hit 2, and then I'm going to increase as a smile, and then I'm going to increase as a frown, and then I'm going to decrease as a frown. Notice what I have here, guys. This looks like a vertical tangent. What do you remember about the slope of a vertical tangent? Right, because you said it in your head. It's undefined, which is why when they told me things about the derivative, they had to skip over 4 because f prime does not exist at vertical tangent. Okay, so you'll have some of these to practice for homework. Let me know if you have questions. Come to office hours, but otherwise, have a great day.